All right, so for worksheet 1.4, first of all, there were two tiny little mistakes on the answers, so let me call those out real quick. So first of all, 7C, it said the answer was 2.86 meters per second. It should have just been seconds, 2.86 seconds. And similarly on 15, I made almost the exact same mistake. On 15, the answer said 51.6 meters a second. That should have just been meters. So I apologize for those two little typos. And if it confused you, then I'm sorry. All right, so I want to talk very quickly about one thing on number 7. And I need to run through the answers for number 10. And I should probably talk about the velocity time graph at number 3. Those are the 3 things I want to do. What questions do you guys have for me? Yes, Brianna. Number 8. I can do that. What else?
Number 9.
Number 9. I can also do that. Anything else? All right, let's start with those. Yeah?
You said answer 6B.
6B is 13 seconds.
What about 7F?
7F, the answer is whatever 2.86 times 2 is, so 5.72.
What about 11A?
Holy moly. 4 seconds. Yes. Yes. Okay, so we just had a bunch of requests. Let's get through those. So here we go. Number 8 was the first request I had. So here we go. Number 8. It says, on the moon, the acceleration of gravity is a little different. Ivan, the astronaut, is given the task of determining the value of gravity on the moon. Ivan throws the ball up into the air at 6 meters a second, and the ball lands after 7.5 seconds. Calculate the acceleration due to gravity on the moon. So, for these problems, if you're struggling with them, the first thing you should do is make a drawing. All right? So the ball begins presumably on or close to the ground. Ivan throws it up. Eventually, gravity will pull it back down. Kabam. You are told that he throws it at 6 meters a second. Please make sure you guys understand that velocity is not the velocity on the way up. It's the velocity when he first throws it. A lot of times people think that that's the velocity the entire time it's going up, and that's not right. It's just the velocity when he first throws it. All right, Ray, will you spin around for me? All right. What else do we know? We know the velocity at 2 other points. Somebody tell me one of them. Yes, Tim, give me one.
We know the top is 0 meters per second, and the bottom is negative 6 meters per second.
Very good. Wait, what'd you say? Negative who?
Negative, is that 6?
Yeah. All right, is everybody good with that? So, if you are struggling even a little bit with these problems where you throw something up in the air or you roll a thing up a ramp and it comes back down, I would start out with a drawing like this because it will make your life easy. Okay? Now, the problem tells you that it lands, what does it say, 7.5 seconds? How's it worded? The ball lands after 7.5 seconds. And if you read the whole thing, it makes it sound like it's the time to get from here to here, right? So that time is 7.5 seconds. So let me pause there for a minute. I don't remember who asked about this one, but does this make sense? All right. So did you, by any chance, make the final velocity 0 and the time 7.5? Do you see why that doesn't work? Super common mistake. Everybody good with that? So from here, now we can find the acceleration. Vf minus Vi. So Brianna, what should my Vf minus Vi over t. What should my Vf be? Negative 6 minus Vi is positive 6 all over 7.5. And so it gives you negative 1.6 meters a second squared. Cool? Everybody good? Yep. Jody?
I'm just making sure like my process is correct because I got the same answer. I just cut the time in half.
And make the final velocity 0. That's perfect. Yep, that also works. As long as you remember to cut the time in half. Everybody good? All right, so that was 8. Number 9, a brick and a feather dropped off a building. If we ignore air resistance, which hits the ground first. That was the whole point of the little paper and book demo I did, right? So if I drop a paper like this, it falls slowly. I don't want to know, do I? So without air resistance, what would the paper do? Fall at the same rate as the book, right? So number 9 should be, they should hit the ground at the same time, right? Somebody asked about 12, so let's do that one. Number 12. It says a ball rolls up a hill at 5.5 meters a second and slows down at 1.3 meters a second squared. What's the velocity after 6.3 seconds? So it's about a ball rolling up a hill. So make yourself a drawing. Here's the hill. Here's the ball. It's going to go up the hill and eventually come back down, presumably. You are told that it is rolled up the hill at 5.5 meters a second. That's my velocity there. Let me pause there for a minute. Is everybody okay with that much? Good. Okay. It says it accelerates and it slows down at 1.3 meters a second squared. So because it's meters per second squared, you guys, that means it's going to be my acceleration, right? Now, I realized halfway through writing this, I didn't finish this drawing over here. Okay? Again, remember, once you get to this point, fill in the other values. I know the velocity at the top has got to be 0, and the velocity down here at the bottom has got to be negative 5.5, right? So, what's my velocity doing, you guys? It's decreasing, right? That means something. It's going to affect one of these numbers, right? My acceleration has to be negative, because there's no way that my velocity can go up by 1.3 to get me from 5.5 to 0. It's got to decrease, so it has to be negative. Cool? So my guess is that if people made mistakes on this, they probably forgot that negative sign is my guess. Yeah? Do you understand why it needs to be negative? Everybody? All right. So then the question says, what's the velocity after 6.3 seconds? So Vf is Vi plus A times T. So here's your Vi, here's your A, here's your T. Plug in your numbers. Cool? Alrighty. The answer to number 12 ends up being negative. What's the significance of that negative sign, Laura?
Because every second velocity is decreasing by 2.7 meters per second.
Oh, sorry. No, that's okay. I think I steered you in the wrong direction. So the acceleration is negative, and that's because the velocity is decreasing. What I was trying to say and did a crap job of saying is that if you solve for VF, once you solve the problem, the answer ends up being negative 2.7 meters per second. So what's the significance of this negative sign? That it's coming back down, exactly. Everybody good with that?
Yeah.
All right. Okay, so I want to talk really quickly about, I guess, numbers 3 and 7. I guess, why don't I read the answers to number 10 real quick? Otherwise, yeah. Okay, so here's the answers for number 10 real fast. Number 10, the chart above represents the motion of the bowling ball. We've done this before, right? So for A, the acceleration ought to be negative 5 meters a second squared. How do you know? Because the velocity is always going down by 5. B, how long does it take the ball to get to the top? Is 4 seconds, because that's when it hits a velocity of 0. C, velocity is positive on the way up for the first 4 seconds and negative after that. D, the velocity is always decreasing. So E, the velocity is always, or sorry, the acceleration is always negative. F is a stupid question. When is the acceleration increasing and when is it decreasing? Well, look, your velocity always decreases by 5. That means your acceleration is always negative 5. It's constant. Okay? In this class, the acceleration for any given sort of chunk of a problem, the acceleration will always be constant. If it's not, you need calculus, and that's for AB. All right. And then finally, 10G wants a velocity time graph. So for 10G, here's what we know. We know that the velocity begins at 20, and at the end of 8 seconds, the velocity is negative 20. Right? So the velocity begins at 20, ends at negative 20, so just draw a straight line to connect the dots. Connect the dots. How do I know that this has to be a straight line and not curvy or wavy or... Because what? Anybody fix that up? Why does this have to be a straight line? Sure, you know what you got, Laura? Good, the acceleration's constant, right? So that means that every second, the velocity decreases by the same amount, right? Every second, the velocity decreases by the same amount. Cool? Good on that, you guys? All right, so I guess that nicely leads into question 3, which also asks you to make a velocity time graph. It's almost the exact same thing. Velocity time. Your velocity begins at 29.4, and after 6 seconds, it's negative 29.4. So there's a graph for number 3. Oh, there's a chair. Good, guys? All right. What are the ones we need to talk about? Did I miss any? Yeah, what do you got, Jenna? 7 who? E? Yes. Excellent. Was there another hand up too? No? Okay, cool. I was going to do one from 7. I'm glad you have picked one. All right, so the reason I like number 7, you guys, I keep talking about this idea of time intervals. Okay? So all of number 7 is about this ball that's being fired up into the air at 28 meters a second. Right? But then there's parts A through F. All right? Each part, A through F, corresponds to a different time interval. All right, so number 7, here's the deal. You've got a ball fired up into the air. So I know that the velocity here is 28 meters a second. I know the velocity at the top, everybody, is 0. I know the velocity when it gets down to here is negative 28 meters a second. So what did we ask about? E? All right, so question E says, how long is the ball in the air for before it's moving down at 12 meters a second? All right, so here's the deal with E. The idea is somewhere between here and here, there has to be a point where it's moving down at 12 meters a second, right? Okay, so if I want to call this a velocity, what do I have to do to it to ensure my accuracy? Make it negative to indicate that it's coming down, right? So is everybody okay with that? All right, so Gianna, what am I trying to find? The time to get there, right? From where? What do you mean when you say 0? T equals 0 or V equals 0? Good, when T equals 0, right? We're trying to figure out how, it says, how long is it in the air for when blah, 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 blah. So here's where it starts being in the air. So I'm looking for the time it takes to get from here to here. So there's my time interval, from here to here. Everybody good? So for that time interval, here's the stuff I know. I know my VI is 28. No, that's okay. It wasn't. I didn't make it clear I was talking to you, so you're good. VF is going to be negative 12 as opposed to positive, like in part D. My acceleration is negative 9.8 meters a second squared because it's about a ball being thrown or dropped. And you're looking for time, right? Cool?
I think, like, I know how to get to it, I just got, like, a slight, like, it was 4.1, but I got, like, 4.5.
Oh, if you're off by, if you got 4.05, then I would say you're okay, because that rounds up. So, I don't know, I wonder if you just subtracted wrong. So, your equation is VF minus VI over A, right? You rearrange. So you end up getting negative 40 over 9.8. Negative 9.8, I guess. So that'll give you about 4.1 seconds-ish. So I wonder if you just typed something into your calculator for me. All right, are we good, you guys? Questions, issues, concerns, anything I haven't talked about that you'd like me to talk about? Okay, so the rest of the time today is yours to work on worksheet 1.5. It's, like I say, it's long, so use the time. It's due tomorrow. Tomorrow we will go over that in probably more detail than you want. And then we're going to do another target check either tomorrow if there's time, or if not, which I suspect will probably be the case, then we'll do the target check on either Thursday or Friday, whichever day you don't do the lab. It's like half the class is going to do the lab Thursday, half the class is going to do it Friday, and then we'll have another activity for the non-lab Tuesday. Follow? Questions? Okay, the last thing I will say before I set you free, on day 1 or 2 of class, I gave you a big long list of equations, right?
Yeah.
the upper left-hand corner of that sheet has a little section that says linear, and it's like 10 equations or something. Okay, at this point, we've learned all those equations. Those are the equations you'll need for the homework. They're the only equations you'll need for your next test, which is a week from Thursday. Yes. No problem. You get that equation sheet. I'll give you a clean one on every test. Okay, I don't want you to type yeah. Good? Yes.
I know I didn't do it right
You're all on the get from 24 down to negative 2.
I can do that. I wasn't sure if it was a straight line or because this is close to slowing down.
She doesn't start slowing down until she starts slowing up. For reasons we'll learn about once we get to. Raquel, you're on deck, then John. Actually, I'll probably go all the way around. I think we're going to be a few minutes. We'll get John and then we'll help.
I didn't read the question.
I think I got it.
Right. So you're good?
Yeah, thank you.
So any of those problems, the velocity I give you is the velocity that they have when they first get there. Yeah. Oh, the video? I got it. Yeah. Please, that'd be a great use of your time. Okay. All right. So, Raquel, give me 2 minutes. Let me get Jenna, and then I'm on my way.
Oh, no. We don't think it's you don't need it either. No equation. So what's the plug in equal in 1/2 x?
Very good. Yeah, mine's negative.
0 6. Alright. Yeah, so 75 equals
Well, we're trying to find it. So I guess you could, if you wanted to, you could use your equation to find it.
Oh, that was like
Okay, there's
a second.
It's probably quadratic formula, but, well, yes, but you don't have to. So this one. Cool. Does that make sense? If this had resulted in you having to use the quadratic formula, then I would say use this guy first, and then find your time. Okay? You are very welcome. Good job. So, quick. Yeah.
That's all you know.
It's always moving that direction. So let's just call that so I mean, we thought about one of those instead of thinking it was down, let's think starting at the top. If you want to get negative, then you gotta think everything. Because I say this is one of the things we're going to talk about tomorrow. What are you trying to find in that problem? What variable is that? Yeah, so what, like, is that? Yeah, A over X. You did. I figured out as the velocity is going to go. But that's only at the end of that. So it takes 1 second, and it's end of 1 second, it finally gets to be 3, the velocity is 3. So this is less than that. You spend most of the time going forward.
Yeah.
Does that make sense?
Yeah.
Okay. That's super confusing. People always get messed up on this. Okay, so, let's use green. Okay, this one, are you good with it?
Well, I'm trying something.
And I like the draw. Velocity starts at 18,
What?
goes to negative 18. This one is one of those things.
Oh,
When I tell you the acceleration,
I just want to get to 18.
acceleration is -4 meters per second squared. Okay, then the screen is saying -4 meters per second. Are you good with that? And you can more out of 8. Okay. Alright. Velocity graph. Well, you showed me that you knew the velocity went 19 minutes. Right? And it takes 9 seconds. So you must be 18. Cool. Position time.
Forward.
So do you understand why the position graph would be a problem or no? So pretty much. So position time. So it's the constant velocity. Position. So what would it look like if you not moving forward, fast, forward? Okay. What about if you're still going forward? Stop, it would be
Oh, that formula, right?
going backwards, so it's not.
No, I'm sorry.
Yeah, it is. In this problem, you're rolling a ball. So at the beginning, it's going to be going so fast, but as it goes up, it slows down, stops. And it goes down real slowly, down real faster, down real faster. That's this guy. Cool. Alright, down here. Because you're going to the wing,
I'm on 3A.
well, eventually it's going to go backward. But it's certainly not going to keep going forward faster, right? You have to speed it up, it's got to slow down. Back, right? Velocity start at 32, eventually it'll get to 0. Eventually it'll be negative 32. So because of the last cool. Finally, on part 3, you understand now that the first week had to go down and stop. So show me on my drawing. What do you try to find it? Yeah, I think from here to here. It says how long after it's thrown does it stop? Right? B. Well, no. So there's nothing magic about this here, just define the velocity for 5 seconds. If you solve it, you end up getting 12 meters a second. You know what I mean with this negative sign on here?
Right.
Because the idea is the velocity gain at 32. If you decrease by 4, for 5 seconds.
I would see like doing 60. Yeah. 6 what? That's how many.
5, 60. Smiley face. Where are you going? So let's go back to the front. So show me on the ground what we're trying to find. How long it takes to get from there to there, right? So what we're trying to do is we're trying to find the amount of time it takes to get from an initial velocity of well, that would get us all the way back to the beginning. 0. Yep, 0. Well, you don't need to know your acceleration, right? Follow? Sure. Alright, and then on the back, we're going to remember it's object is going west. Speeding up.
Six was easy. I'm not gonna
The velocity decreases.
That's 6 done.
The velocity decreases, the acceleration is negative. Velocity increases, the acceleration is positive.
Negative 15 squared. Divided by.
Well, right. Okay, but so moving goes the opposite. So why is the velocity negative?
It's all mental, bro. You think too much, bro. You gotta like. I specifically crossed it off too because I didn't know what to do.
So having a positive acceleration. So
Ryan, you just gotta think more with your head.
west is speed.
Really? How high will we go? I don't know. Oh, you're already on. I'm catching up on the roads.
But then it's speeding up. So by the time it gets over here, now it's going at, I don't know, 20 miles an hour. Because it's going west, alright, do these velocities.
Alright.
Next is right. You are how many 1-4 go?
The acceleration.
Alright, well, in case of any outlets, time to get started
Like,
on
what's your
4 or 1-5 rather, and, let me
Oh, right, so you have to
This is
do.
not me being defensive, I'm not, so why temperature decided? No.
Working as for.
Oh, so 8 to negative 9. Got it.
If I put the answer right there, you would look at it and go, oh, well, obviously, the answer is blah, blah, blah. You would have to think about it.
That's true. Maybe you can put it on the
So a lot of the times, yeah, I should start. I got you 1 second. So a lot of times it's like the answer 0, or you know what I mean, something like that. So. And if I forget to tell you the answers to the smiley faces, do we do the data has written? Okay. Some quick answers.
Okay, so before time
Oh, initial.
I like how it's fun.
Or us.
It's not applying 2 times me.
Only way I get things done is if I press.
For now,
It's going.
whether it's going up
Yeah,
or it's going down.
it's fine. I don't know the way.
Goes up, goes from positive to 0. And then on the way down, it goes from 0 to 1. Either way, you're positive.
What was I complaining?
Alright, so there are 2 one of them I'm more worried about than the other.
Ryan, you can set man.
The initial velocity is 14, the acceleration is negative 3.2, the time is 8.
Oh, negative 3.2.
You want to run it for a week? What, you know, you're right.
So, if number one is that's issue number one. What is the 40-year rate?
Sorry.
All you
I actually didn't hear him.
yourself, right? You don't care about grid, you care about the ball. Right? So the balls can go up some distance, come back down that same distance, and then go down 40. It's negative. Because it lands 40 meters below the start. All this is position 0. Positive, 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 still positive, 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 now negative, negative, negative,
I got a charger.
For what, John?
Okay, so there are two ways to do it.
For what?
No,
you have
Either
Whatever
one
Joey needs it.
easy in the sense so if you just want to do it in one step, then and I haven't grabbed it on the way
John,
out.
can you charge it?
No, no. So you didn't have one.
I know.
Which works.
Why did you charge it?
Good contract formula.
Sell it? $5.
One positive and one
$5.
Yeah, they will. No.
Okay, so that's one option.
Unless you
Let's see what?
Sorry, some other way to do it. Or
I'm saying whether or not.
Oh, come on.
Golf is great.
Right now.
I'm going to go to the end of the back and we'll talk about something. Okay, Emma is the bottom line and one bothering you. Okay. You want me to sign that? Yes. I'm going to sign it. And we'll get some learning.
Alright, here, 2 times.
Oh, wait, you gotta use it.
I think it's number 5.
Yeah, what are you? I got 70. How is this? Huh? 70. Just. Well, it's not bad. Alright, so what's funny here? Negative acceleration, and then you don't know your final, but you know you're in this sports game, and then you're
The displacement
I did.
is 1 half VI plus VI times T.
Make sure you have a negative acceleration. Finish the
Since you do the VF though, since you know the VF is negative 14 from the previous problem.
Yeah, that's why. That is exactly why. This is not what we want. Yeah. So yeah, but it's all good. Because it's your V out squared minus 0. Oh, there it is, 225. Oh, I think first 225. And then one of the high gets from A, right? Your calculator is smart than all the operations. Calculator, here's that. Maybe 25. And you divide it by 2. Regular calculator. Whatever that is, was multiply. What you really want it. Divided by. That was not what I said. I said it's a different question. You said no. I said yes. Oh, I got Lauren, Milena, and Nate in that order. Yes. Have you done 2 and 3 yet? Okay, talk to me about 2. 2 is easy, right?
Yeah.
So every second?
Every second.
You were just contradicting yourself. What did you tell me about the velocity?
It's constant. So it doesn't.
So what does it mean to go 3 meters per second? Every second you go 3 meters, right? As long as your velocity is constant, you can go the same distance every second. But in number 3, it's harder, right? Because you don't go the same distance every second, right? Because you're accelerating, right? And that's all number 1 is trying to get at. The idea that if you accelerate the distance you travel each second changes. Which makes it harder to figure out how far to go, you know what I mean? Good. You sure? Alright, Milena was next. I got Milena, Nate, and then Deanna. Don't remember. Let me look. You can look at that in your VI. So, there are 2 ways you can do it. Neither of them are super easy. That's what I would think. That is what I would think. Just find your VI. No. Because the only way that you can make it 20 is if it landed back on the bridge. But it doesn't. Because it goes up and then it falls down below the bridge. Do you know what I mean? Sort of. It's 42, no, you know there's like, it's 42, sort of.
Wait, is that bomb there? Like, for this one?
Okay, the ball starts here, right? It goes up, and then it comes down. That's down. It's negative 42. And then the 43 minutes below the starting point. Good? You're all very well. Page 9, sorry. Honey! Okay. I debated with that. Wish I had it. So So, do you understand what the blue distance is? Yeah, reaction distance. Right? It's like, oh, please, squirrel. And then, and during the time it takes you to go, you travel 6 meters. Right? So,
Why did your brother try to sell her?
you're driving down the the time it takes for you to go see the squirrel and see the squirrel.
I don't have.
What's your velocity going to be during that time? Yeah. So basically, that's the how long does it take you to right? Going 30 miles an hour.
This wasn't random.
Cool. And then, what is your velocity?
So we might get to those.
Giving the eye, the are all zero. John, can I answer your question?
I feel like you would like to every day for after. Oh boy! Oh goodness!
Exactly. If your initial velocity is negative, that would be slowing it down. Oh, it's wrong. Sam minus the that will cause problems.
I have my sister's next software.
I never thought about it.
You're very welcome.
Remember, it's like,
Guerrero, Sorry?
I'll come to sister if I want to watch.
Cool.
I parked like all the way.
Yes. Perfect. Hey, Elizabeth, I've got to stop recording.